So whenever we're studying any subject in school, one of the things that we want to look for is patterns. It doesn't matter if we're working in mathematics, if we're working in English, or in history, or in science. We always want to look for patterns that we can then use to establish predictions for the future. So we're going to look at mathematical sequences and mathematical patterns in this first section. So the way that we are going to write a sequence in mathematics is we're going to say a sub 1, a sub 2, a sub 3, and then on and on and on. That's going to be our sequence. Each one of these parts of the sequence is going to be what we call a term. So a sub 1 is the first term, a sub 2 is the second term, and a sub 3 is the third term. Now, the number that goes right here is going to tell you the number in that particular sequence. Instead of writing 1, 2, and 3, where we would write our sequence, we can also, or where we write the term of the sequence, we can also write it as a sub n plus 1, and a sub n plus 2. Now, what this tells you is that if this is, say, term 0, then what we would do is we go 0 plus 1, and that would be term 1. If this is again term 0, then 0 plus 2, this becomes the second term. If we were to say make n into 9, then this would be 9, this would be 10, this would be 11. You could also do a sub n minus 1, and that would then give you a sub 8, or the 8th term in the sequence. Another way we can look at this is if we say that a sub n is equal to 2n, what we can do is whatever number that we plug in for n, we'll also substitute in in that equation. So an example of this is if we have a sub 1 equals 2n, then what we're going to do is we're going to substitute that 1 for the n, and that's going to tell us 2. If we do a sub 2, that's going to tell us 2 times 2 and give us 4. And what you can see is we've just gone from 2 to 4, so we've added 2. If we do a sub 3, then we get 2 times 3, which is 6. And again, what we've done, going from here to here, we've added 2. So now we know that each time that we move up one term in the sequence, we're going to add 2 to the output. Now coming over here to problem number 1, we're going to do this exact same thing. What the book wants us to do is to figure out what are the first 10 terms, or what are the first 10 outputs in this sequence. So if we do a sub 1, we're going to replace this n with 1. So 3 times 1 is 3, minus 2 is equal to 1. Then if we do a sub 2, 3 times 2 minus 2, so 6 minus 2 is equal to 4. You can see what we've done going from there to there is we've added 3 units. So then if we go a sub 3, 3 times 3 minus 2 gives us 9 minus 2 is 7. And you can now see that every time that we're doing this, we're adding 3. So if we do a sub 4, the next thing that we should get is 10. So 3 times 4 minus 2, 12 minus 2 gives us 10. So now, instead of having to go through and actually work out the equation each time, we can instead just say we're going to add 3 to the previous result, and that's going to give us the next result. In the last section, you are asked to use an explicit formula to find the output for a certain formula that you were given. Now again, explicit means that it is something that you're given, you're told this. So an explicit formula is a formula that you are given. Okay? Now what we're going to do in this next problem is we're going to be given information. We're going to go back and we're going to create the formula. This is what's called a recursive formula. We're going to take it and we're going to work it back to the formula. So in problem number 2, you're given a situation where you've got a box, and then a pyramid is made out of 3 boxes, a pyramid is made out of 6 boxes, then eventually 10, 15, and 21. And what they want you to do is create a recursive formula based off of that information. So let's start with, this is term number 1. So we're going to write this as a sub 1. This is term number 2, so I'm going to write this as a sub 2. This is a sub 3, a sub 4, a sub 5, and a sub 6. Now what you can see is this. As we go from a sub 1 to a sub 2, we increase the number of blocks by 2. As we go from a sub 2 to a sub 3, we increase the number of blocks by 3. And then as we go from a sub 3 to a sub 4, we increase the number of blocks by 4. So here's what we know. Every time that we move from one term to the next, we're actually increasing the number of blocks by the next term. So going from a sub 1 to a sub 2, this 2 and this 2 are the same. This 3 and this 3 are the same, and on down the line. So what we know is that we're taking whatever we had previously and adding n to it. So the way that we're going to write the recursive formula is this. There's two parts to it. The first is to establish what is the first term in, or what is the first element or term in the sequence. So a sub 1 is equal to 1. That's the first part that we need to establish, because that's going to allow us to actually use the recursive formula. Now the next part is to determine what is going to be the nth term of the sequence. So we're going to say a sub n is equal to a sub n minus 1. Now what we've got to do is we've got to figure out what is happening to this right here. Every time that we move from one term to the next, what are we doing? Well, we're adding n. So in this case, what we've got is a sub n minus 1 plus n. This right here is the recursive formula, in addition to the a sub 1 equals 1. So this is what we're looking for right here. We know that we're adding the nth term every time that we're moving up to the next term in the sequence. Now that we've figured out what the recursive formula is, let's look at why this actually works. So we're given that a sub 1 is equal to 1. And let's say that we're looking for the second term in the sequence. So we want to do a sub 2 is equal to a, and then we're going to go ahead and put in 2 here, minus 1, plus, and again, this is going to be the second term in the sequence, so plus 2. So now we have the second term is equal to a sub 1 plus 2. Now that we're back to a sub 1, we already know what a sub 1 is. A sub 1 is equal to 1, so we can replace that now with we can replace a sub 1 with 1. So 1 plus 2 gives us 3, and that was the second term in our sequence. Now if we go back and do this for a sub 2, or looking for a sub 3 rather. So a sub 3 is a, and then sub 3 minus 1 plus 3. So we get a sub 3 minus 1 is the same thing as a sub 2. So now we can take this 3 and replace a sub 2 with 3. That gives us 3 plus 3, and you can see that that's 6, and that is the number of blocks that were stacked to make that pyramid. So we went from 1 to 3 to 6.